Hello everyone, welcome to Maths with Mr. JN. Today I'm going to show you how to solve this exponential equation which raised 2 raised to the power of n plus 2 raised to the power of n plus 1 equal to 16. Solution: 2 raised to the power of n plus 2 raised to the power of n plus 1 equal to 16. Now we change everything to base 2. We have to change the right hand side, which is 16, to base 2. That will give us 2 raised to the power of n plus 2 raised to the power of n plus 1 equals to 2 raised to the power of 4. Because if you multiply 2 by itself 4 times, gives you about 16. Now, in law of indices, whenever we have a raised to the power of n plus n is equal to a raised to the power of n times a raised to the power of n, which we are going to apply here. That is, we have 2 raised to the power of n plus 2 raised to the power of m times 2 raised to the power of 1 equal to 2 raised to the power of 4. 2 raised to the power of 1 is the same thing as 2, so everything we change to 2 raised to the power of m plus 2 times 2 raised to the power of m equals to 2 raised to the power of 4. How many 2 raised to the power of m do we have? We have 2 plus 1, which is 3 into 2 raised to the power of m equals to 2 raised to the power of 4. At this point, we divide both sides by the coefficient of 2 raised to the power of m, which is 3. When we divide both sides by 3, we have 3 into 2 raised to the power of m all over 3 equals to 2 raised to the power of 4 all over 3. 3 we cancel 3, left with 2 raised to the power of m equals to 2 raised to the power of 4 all over 3. At this point, we introduce logarithm. When we introduce logarithm, we have log 2 raised to the power of m equal to log 2 raised to the power of 4 all over 3 in brackets. Then in power log, whenever we have log p raised to the power of x is equals to x log p. Also, in logarithm, whenever we have log m over n is the same thing as log m minus log n. Right now, we are going to apply these two laws of logarithms in the above expression. Then, log 2 raised to power m will change to m log 2, which is the first law, equal to, now we apply the second one, which is log of 2 raised to the power of 4 minus log of 3. This is the same thing as m log 2 equal to 4. Because this is power log, we have to apply the first one, 4 log 2 minus log 3. Next step, we divide both sides by the coefficient of m, which is log 2. If we divide both sides by log 2, we are having m log 2 all over log 2 equal to 4 log 2 minus log 3 all over log of 2. This log 2 will cancel log 2, left with m equal to log 2 will cancel log 2 here, which is 4 minus log 3 all over log 2, because log 2 cannot cancel log 3. Then our final answer will be m equals to 4 minus log 3 over log 2 are a normal base, which is base 10. To change it to base 2, it will change to log of 3 in base 2. So this is the final answer. Then if we continue to make it to be like number, m will be equal to 4 minus Log 3 over log 2, when you use calculator, you will have 1.585. M is equal to 5 minus 1.85 will give us 2.415 as the answer in four figures. Now we want to check if our answer is correct. Now check. What we do, we write down the original equation, which is 2 raised to the power of m plus 2 raised to the power of m plus 1 equal to 16. Put m equals to 2.415. Then this will change to 2 raised to the power of 2.415 plus 2 raised to the power of 2.415 plus 1. Let's check if it will give us 16. 2 raised to the power of 2.415 plus 2 raised to the power of, when we add 2.415 plus 1 will give us 3.415 equal to 16. When we calculate this, we will have 5.333 plus 2 raised to the power of 3.415 will give us 10.666. When you add 3.333 plus 10.666, you will arrive at 16 approximately as the answer, meaning 16 is equal to 16, which satisfies the equation. If this helped, please subscribe, like, and share. Thank you. Thank you very much.